Hello and welcome back after a pleasant weekend to Learning Rust with Good Oxide. Hi Sid, good to see you.
Sebastian.
Welcome back, and today I think it's all about errors. Fun fact, the last session that we did, we ended with this where we kind of shoehorned in the results, which led us to think that today we want to talk about errors a bit more. Also, that never compiled and we never ran it. So just before the show, we were fixing this, do something that we also never ran, but at least it compiles and it has the potential to work. This is something interesting here that we will get to once we talk about generics. So stay tuned. This session will come sometime later. This is what's called a weird cliffhanger that doesn't work. Now, I think for errors, we need to do something that can error. And also, I mean, before we do, yeah, actually, let's do that by hand. What are errors anyway? Because we already know about results. And we already know that we can return results here. So a result has a good value, that is unit in this case, so nothing. And it has an error value, literally, that we can also specify as unit. And now as we return something that is valid, if you run it, everything is fine. And if you make this an error, now Rust knows that it's not good. So it's an error code, exit code 1, which would tell your bash that the program didn't work. So that's easy, and that's in main, that's special as well. That's specifically implemented, and that's the kind of top level place where you can use results, and hence where we can use this kind of error type. So apparently unit implements something that is this error thing. And I can tell you that we can even implement our own. For example, the following function. Again, fn add 1. And we have a value that is a u8. And we have a result that is either the value with 1 added, or we have an error that indicates what the problem is. And the problem, there's only one possible problem for us, really, but we might say we want to really hammer home that this is an overflow error, so that people can, use code to understand the error more clearly. Maybe we say how the overflow would have happened. Maybe make this an unsigned integer, and that it can kind of underflow and overflow. I think ultimately it's the same, but that way we have some more information here to encode in our overflow error. Out of bounds. Something like that. Lots of camel casing here. Okay. So let's work towards getting this error, which we want to use to communicate more clearly what's wrong, right? So that's the point of these error types. This is how it's used in most cases. The error variant of a result. So what's in here?
So this is really just a unit struct, no special functionality with it. It's just a name, so it's something specific that you can assign.
Right now it is. And we will work towards getting this to work at all, like just by letting the code drive us. And I think this is how we can discover what errors are for Rust, why you would use them, how this relates to results, and also how to not have to do all the work that goes with that. So I think this is the goal. Let's do it. So we already know that we have a checked add. So yeah, we have add 1 here. Let's actually make this more complicated. Let's make this an adder, and the adder gets to hold on to some to something that is a number. We even reference this, which you wouldn't do because it's so small that number, you can just copy that around. But I want to say we don't own this. This is why I have this header in the first place. It's over-engineered, don't do this. It's just for the example to make this a bit more complicated, I guess. And maybe we don't need that complication. We'll see. So now we can implement some functions on that, or some methods on that header, all for that lifetime. And we can add and subtract. So add 1. And now we go with exactly this. We can, let's make it an I8. That's going to make it easier. I should have just taken this, right? It's the same. And now we access our the first argument, self, that's the instance of the header. And now we can access our fields. This is a struct, a tuple struct. So there's no names for these fields, but only numbers. The first one, that's going to be our number. And interestingly, right, this is a borrowed number. But
so you need to dereference it, right?
I need to dereference it, but that's one of the few places where something happens automatically. It's called auto dereferencing. So you don't have to write that all the time. It just does it for you because there's no other thing.
Okay.
Yes. So that works. And think about it. If that wouldn't work, I would also kind of like, how do I get access to my fields? Do I have to dereference myself too? Because that's a borrow as well. So I'm
You'd have double. Yeah.
Kind of a lot of asterisks there, and I think this is why they did that. It's just cumbersome and not useful in this case. Okay, so now we access our first field, and we just access a method on that integer, which is pretty cool all by itself. And then add 1. We don't need the value anymore, actually. We now have this. And out comes an option. And we do it like we do it before. Oh yeah, that's an I8. Because I don't just change type by adding something. This just stays the type. And we know if I increase the value, it can overflow. So here I would like to indicate that it's okay, or we have an out of bounds error with an overflow. And you see that it already is much happier than before. Let's see, can I do something automatically here? No. That would be cool, because now I, of course, kind of indicate I would like to have an enum for this, which is saying overflow. And that will already work. So let's try to do this. We have an header to which we give 125, 6. It has to be borrowed. Then we add 1, and that should be fine. Oh, unwrap does not work. Why is that? Okay, out of bounds error does not satisfy debug, because unwrap needs debug for both types that are in the result. Because if it panics, it wants to tell you the value that caused the panic. This is why. And you see that here. We are kind of, there's always generics when you go into these, right? So we never talked about generics, but I guess we kind of get some involvement with that without getting too much into detail. So here there is no trait bound, but here it is. So we have an implementation that says for all results where there's any t, but the error type implements debug. So that's a constraint. So only for e's where the error type implements the debug trait. And debug is a way to format the value at hand. So T does not need debug, only E. And if this is not, if the constraint is not satisfied, then unwrap simply does not exist on that particular type. So this is what I'm trying to do, right? And this is the message. This is why I can't, this is why it's just not implemented. Trade bound not satisfied. But it can phrase that a bit more clearly, I guess. So that's nice. In order to implement debug, we just auto implement it. So just print something that resembles this, right? It prints what you have in code essentially, and that will work. So that's expected to work. That's cool. And now I think that should already fail. Let's see. And it does. Cool. So now we see this debug print version that says just overflow. Value overflow, not too bad. Main panic because result add called result unwrap on an error value. And unwrap always must be an OK value. It can't be an error, otherwise you panic. And that's that. Okay, so that's nice. And now the other, in the other direction, just sub1, and all that should be the same except for here. Checked sub 1, and then the out of bound error is underflow. Okay, should work just the same. Yeah, okay, that's just minus that. Sub 1. Okay, so the first one should now work, the second one should be this kind of error. What am I not seeing? I mean, maybe it's just that, and I'm not exactly the computer science guy. Yeah, I'm not the computer science guy. Okay. All right. So we can reproduce this. That's great. But there's still no sign of an error. I just used any kind of to Rust. There's nothing special here. It's just some error type. It implements something that is in the error variant of a result, but I can't really use it as an error yet. Which means usually you use errors by not using unwrap, because that crashes your program. We want to never write unwrap in a production program. But instead, we would like to have some sort of error handling that says, or that allows us to avoid, if there is some good value, do something nice. Otherwise, if there's an error, return. Okay. And then we want to return that. Did you notice something? Something changed, something strange happened. I don't know what. So I can't return the V here because that's an out of bounds error. Maybe I should make it at least E to signal that it's an error. I do have to make it a result at least. So I have to wrap it into one of its variants, and we have auto available, so to say, in the prelude of Rust, these variants and OK. So with that, we can always build a new result. And this would work, of course, if you would declare that we want to have an out of bounds error here. Okay. And now I might be able to run this. Let's fix the warning here as well. And we don't actually get into this portion here. Let's make this 127 so we have an overflow. And we see error overflow. So that's pretty neat. It automatically works. Also exit code is 1. And that's a bit unexpected. I don't usually do this. I thought we would have had to do more to do this kind of error handling. from main, but we don't, because apparently if your error variant implements debug, that's all that needs to work, nothing else. And that's nice.
Yeah, that is pretty nice. So you can just basically use enums to kind of categorize your errors and just print out more helpful stuff.
Yes. And in one of our sessions, we already talked about enums, and you can do all the fanciness with structs here. So you can put even more information into the variants to be even more specific about what you want. And this is how errors work. That's the essence of errors. But also, it's a bit annoying to always write match statements, because that's what you have to do. I mean, there is a few things you can do on a result, but there's no such thing as, I don't know, like just try to do this, and if it works, great, give me the value, like this. Like there should be something that makes this easier. Oi. Right. And I think there might even be something that we can use to get rid of all this craft here, because this is something you will see a lot. This will happen all the time. Every time that you have a result, you would have to write this. So you go nuts. And the way to do this, fortunately, is to use the question mark operator. And that's exactly that. So that one will replace the match that we just had. Give me the positive result, give me the OK value, or return the error value. And in addition, potentially transform the error value so that you convert one error into another error. Also happens a lot. Right now, this wouldn't match.
Exactly, I was just about to say, I mean, this only works because the function already returns the correct type of error, right? Otherwise, you'd have to do something to it.
Yeah. And I'm once again a little bit confused because this also works. Like I wanted to have a reason to start doing some implementation of the error trait, but apparently in this particular case, that's not required. So the question mark operator does exactly what we wanted to do. So it very much looks like there's this overflow as before, and now we would see the value because the type system tells us that this is okay. We saw the value and now it crashes here, but we should be able to do this, and now it doesn't crash hard anymore. And this is error handling in Rust. Apparently, it's that simple. Is it really that simple? Okay, let's see if this can be composed or if main is something special here. So if you drop all of this here and then just say do it, it does compose. Okay, so main is not special, which is nice. I mean, I would have hoped for that outcome, but let's be sure. Question mark operator just works, and all you need is debug on your error type. So I wonder why the heck I'm continuously implementing error for like this error trait that I want to show. Why do I implement this all the time? Like my whole foundation of the purpose of this is now removed because apparently you don't need it at all. Huh.
So the error trait would be like debug, but then a specific kind of printing or formatting on how you would display the error?
Yeah. You can do error display instead of just debug display. You can also display it in a form that is for the user. And you can attach backtraces from where the error occurred, which is used for, for certain debugging tasks or for letting users provide more debugging information. And you can also chain errors so that each error can have a source or root cause, And this helps you to, yeah, just nicely bubble up from somewhere deep down to, okay, I couldn't edit your config file because I couldn't write it or something. And here is the error I got from the file system, something like that. And that's pretty cool. Something that question mark operator does that is probably undervalued is to, or is something that you don't value if you always implement the error trait, because it just works most of the time, depending on how you do it, but we try to get there, is that it converts errors from one type to another automatically. And here it doesn't have to do that because it just, it's the same error type, but you don't usually have that in your program. So, or not in every program unless it's this one. So what if you have different error types? If you have another function that, I'm running out of examples here, terrible, which may just, always error, and it's just something that never works. Maybe this is creative enough for me. Let's see if we can just return a string here, an own string. Hello failure. I mean, sure we can, because as far as Rust is concerned, that's not even important for error handling. There's nothing going on here. But what happens if we try to now call this and get out of here? So this should now work, but this should fail. And we see something is not happy here. Let's see what that is. Oh. Okay, fine. So we could still do that. So here you see the question mark operator implicitly performs conversion using the from trait. And that's interesting here, from residual, result, and fallable string. Okay, to that. So this seems to be its type here. And it wants to have the type which is actually returned from that function.
So it tries to convert the string into the out of bounds in this case.
Yes. And now you see that we need some way of expressing all kinds of errors, maybe even with a cause or context information. And this is now where the error trait comes in. Because of course I can hack this out of bounds error to be more, but that would be wrong because it really is good in what it is. I could try this, then I just shift the problem around. So now I have to be able to convert. I mean, this from residual is the first time I see this, by the way. I have no idea where that is coming from. Don't know. But we might be able to implement this. So from out of bounds error for string. Let's see if we can make such a conversion, and then we might be able to just convert all of these into strings. So we implement from out of bounds error for string. That's allowed because our own type, we can always implement from our own types for other types that we don't own. So we can convert our types to some other types that are arbitrary. Okay, so now we have a value, and all I'm going to do for now is to debug print this and to just have some sort of string that makes sense. And now there is no issue here anymore. Only this one wants to be adjusted. Okay. And now we see error failure. And it's so funny that I thought I knew what I was doing, but apparently I didn't, because in my mental model was different. mental model thought error trait is important, but not so much. Cool.
Okay, so what's the strategy here then? If you have a bunch of different error types, you'd still have to find a common, like a base class almost, right? Something that everyone kind of derives from, and then you can always return that base error.
Yes, absolutely. And I think this is also, I mean, that's the only way. And now there's different strategies for depending on who you are or what kind of thing you're actually working on, what you're implementing. I still would love to have a way to, use the error trait, and we can, but we might as well just skip this and say, okay, just use a bunch of crates that help you to do this. So let's go here and just add a crate, cargo add. Cargo add, by the way, is an addition to cargo. So that's not part of cargo itself. And with that, you can easily add crates to your manifest. Otherwise, you would use cargo search, which is part of cargo. And now I say anyhow. And then it tells you, look, I have this. You can now copy it from here. So maybe that's a good starting point because that's what people have. I can copy this and put it into my cargo toml under dependencies. And we're done. And now I have anyhow. And anyhow is, error handling. It's like, okay, whatever, anyhow. It's kind of fun to use it. It takes a moment to compile. This is the only disadvantage. Also, it's probably worth understanding for when to use it. It really is for apps. Because it's this high-level abstraction, it costs you something. These errors, creating them, they might allocate. And that's always something you want to avoid in libraries or anything really that is just an API that you provide, just to keep it slim and lean. But for applications, that doesn't matter. They delegate all the hard work to libraries anyway. And then from there, you're focused mostly on having nice errors. And this is what anyhow can do. Anyhow provides a bunch of types, but there's not too many that you have to know. It's really just a quick glimpse at anyhow. Anyhow results just says, okay, there's nothing to return here, but the error that is in here is an anyhow error. And that one has all kinds of fancy abilities. Like it can create context for you. It can show causes of errors. So error chaining is done with that. It can handle backtraces for you. It does all kinds of cool things. So this is usually what you put here if you want to, because then you know your app, when it aborts because of an error, it will look good. We can try that. You saw I changed this here from our custom error type to a question mark here because I wanted to convert this automatically. And now I think we see finally why you might want to have some error trait implemented here, because string does not implement error in the standard library. And this is where we have to think how to do that. So if you're on application level, you can of course just use anyhow everywhere. Like do it would then rather be an anyhow result, shifting the issue elsewhere. Now we have the issue with our custom types, which still don't implement error. But for this one, we can probably do it. Impl std error for out of bounds error. And you see, maybe one thing, I tend to just write it out like this. Even though it doesn't look super pretty, you can also do it like this and then make an import. Maybe nicer. But usually I don't bother and just go with the long path. And once that gets too noisy for me, then I change things. But that's definitely just me. Oh, interesting. So error needs the type that you implemented for to implement debug, which we do, and display, which we don't. And IntelliJ knew that. So here we have to implement display now. And we can go with a cheap implementation. Once again, we can just write into this formatter here, which is like an output. It's like an output that can receive strings or Unicode, UTF-8 encoded bytes, and can debug print into here as well. Voila. And that's of course not how you do this, right? But if you're as lazy as me, then you may do this. And then error doesn't need anything anymore. So error is mostly being able to display things, or at most it's being able to display things and to debug things, or to debug print things. And the reason for this is actually very explainable, because as you do unwrap, you need to be able to debug print your error type. And this is where debug comes into play, your debug trait. This is really nothing a user should ever see, which also means this is at most for debugging or for, work in progress stuff. This is not for production crates to unwrap, because that just says you don't care, and you definitely should care. There's only two ways to deal with this possibility of error of something not being there, which is either question mark operator, which passes on and transforms the error upwards, or expect, which allows you to, spell out why this cannot possibly go wrong. This is how I do it. I expect these invariants to be upheld. And this is why. Like, I checked this above. Here, it can't ever be a none value or an error value.
So this is something that should never happen, essentially, and it will panic.
Yeah. You could even go as far as say bug, because this is your bug. Like, if you see this, you should probably see it while you develop the program and then never again, because an invariant that should have come before was not met. And that's how I do it. But usually you would put these and let it bubble up. Or you expect things, which might make things easier as well. I mean, expect when you can, when you know it, otherwise bubble up. All right, so now that we can do the conversion because error works. Yeah, I mean, the next thing is, why is display needed? Maybe display is needed again to have something to display for the user. If this thing bubbles up, then we don't want to see debug output for the user level, but we want to see something that is meant for the user. And this is why display is needed. Okay. And what can error do actually? Because apparently there's nothing. Of course, there's something, which is these. They just have default implementation. By default, errors have no source. Type ID is auto implemented. Backtrace not present. And a bunch of these are deprecated here. So there's not too much about an error, but as I said, backtraces and sources, and that's it. That's an error. Plus abilities to print in various forms, to print yourself. And yeah, the conversion, as we saw, is actually defined by another trait, the from trait. And in combination of these traits, you have error handling in Rust. And if it seems a bit complicated or complex, let's say, I think it's complex, then you're right. But also this complexity is needed in order to do what you need to do with errors in an everyday program. But typing all this out is some work, right? Not the end of the world, but...
The more types you have or the more error types you have, the more complex it gets, yeah.
Yes, And we didn't even dig into like all these conversions that you need from this type to this type, and then it bubbles up. And if you have a library, then you shouldn't use anyhow, as I said. Then you should keep spelling out what it can be, and then you have nested errors all over, right? So there's a tree of errors then. The top level thing can then have a bunch of failure modes, depending on where it goes into and which branch it goes into and what really happens there. And that's super cool, because then you know exactly what can go wrong by looking at this type, but also it's a big monster of a type. And then the question is, how would the user of the library even use that? Would they match on this thing and then recover that? Like, is this detailed error handling, is this even valuable to your users, so to say, which are API users then? And that's interesting questions to ask. I answer them by, I don't know, I just do it because it's the right thing to do. Or at least it seems like the right thing to do, to like specify what goes wrong if something goes wrong that is your invariance or something like that, or yeah, bubbling up of errors, without unifying them into this one, which you can't programmatically understand anymore. Here it's just some error with causes that can print nicely, but it's definitely for the user. You would not be able to find out what exactly happened and then programmatically do things differently, unless you want to match on a string or parse a string, and then, you know, be dependent on that, which nobody wants. So this is the differentiation, really. So that's it. Lastly, can we make this build? So string still isn't an error. But always error, of course, could be something like this. Anyhow bail, which is a macro that creates an error based on the string here, which can also be a format string. Anyhow result, like this. And now we just bail out of this one. And it's all hidden what we are doing here. Alternatively, we could just do anyhow. See, so that, yeah, that creates an error. So I still have to wrap it into my result. And that's pretty much it. That's how you mostly deal with anyhow, I guess. And the rest is magic and happens automatically. Interesting, you can create contexts here, which I think is just additional information that you can attach. And then you see how these causes look like. Okay. And this is what you get with anyhow. And yeah, it's the hippest crate right now, so maybe in 2 years it's going to be a different one, but this seems to be satisfying everybody right now. Having come many steps, there is many crates that were the hip ones over time, and they come and go. So I don't know if that's the end of it. I kind of hope so, but if not, I'm happy to refactor. Yeah.
And then the next one.
Yeah, it's a bit like Node or NPM or web development, which is just so fast moving and constantly replacing things with other things that kind of do the same thing but differently. Better here, worse there. But I think the error handling story is mostly better, and this just shows how difficult it is to get it right for everybody, right? I mean, it's not a solved problem, but maybe now we are nearly there, or we are there. So for me, it works for sure. All right. I think that's good enough. Next session, we can try to look at other error handling crates and see what a library would do, or maybe look into GitOxide a little bit to see how GitOxide crates deal with errors, because you have applications that use anyhow, and you have other crates that use plumbing crates, which use two different error handling crates to make that a bit easier, a bit more usable, let's say, less boilerplatey. And we can just take a look at this, and I think that could already be the error handling story, and conclude booleans to options to results to errors, which kind of seem very optional here, unless you unless you start using these error handling crates to get cause propagation and context, which, yeah, you definitely should have. Yeah, cool. I think that could be it for today. And
Awesome.
Thanks a lot, Sid, for joining again. And thanks, everybody, for watching. Have a nice weekend. Bye-bye.
Thank you very much.